Going to go through day two of the SAC. So again, this was getting you to explore your understanding of linear quadratics, and you could have used other functions as well. And because we also went through the square root function here. So this connects onto the same theme as what we've already done, which was looking at a park. So here with the park, we were given different dimensions. So let's go straight down to question one. So for question one, it was focusing on in our park, we were going to have a cycling track. We are going to write the equation of each of the paths A, B, and C using function notation. So a lot of people did not use function notation, so people lost 1 mark for this. Now, there's a couple of things we need to be doing when we're finding our equations. The first one is just going to look at our first equation of A. Because we've got our grid, it's a lot easier to find our rise and run. So for this one, I can see straight away my rise is going to be up 7, and my run is across 5. So that's the first part. The second part, I'm going to use my formula of y take away y1 is equal to m x take away x1. I'm just going to substitute my values in. So in this case here, I'm just going to use this value here, which is when x is 2, y is 0. So that'll be y take away 0 is y, m is 7 over 5, and x take away 2. I'm going to rewrite this now, but in function notation. So I've got here my first function is described by the domain, and in this case here, our domain is between 2 and 7. So I'm just going to put that in 2, 7. It's going to be graphed with all real numbers, and our function is equal to, and I'll finish this off, 7 over 5 times x is 7 over 5x, and 7 over 5 times negative 2 is negative 14 over 5. So that's my first equation in function notation. My second equation, I'm just going to do exactly the same thing. I don't need to use a formula because I've got the grid right here. It makes it super easy. So my rise is 2, 4, 5. And it's, of course, negative. My run is 2, 4, 6, 8, 9. So that means I've got it as negative 5 over 9. Now I'm just going to substitute that into the equation. Y minus y1 is equal to m x minus x1. So again, I'm just going to pick one of those points. I'm just going to pick the 7 and 7. So I'll substitute that in. Y take away 7 is equal to my gradient 5 over 9. X take away 7. I will expand and add 7 to the other side. So I've got negative 5 over 9x. Negative times negative is a positive. 5 times 7 is 35. So 35 over 9 plus 7. Just so I can write it in the same form, I'll make it out of 9. So 7 times 9, 63. Okay, now I can write this in my function notation. So that is the f is described by my domain. My domain is from 7 all the way through to 16. For real numbers. And my function is f of x is equal to negative 5 over 9x. 63 plus 35 is 98. So it'll be plus 98 over 9. That's my second equation. The third one, we know it says y equals 2, so we can do that straight away. 3 is, my function is described by the domain of 16 to 20 for real numbers of f of x is equal to 2. So we've got all three of our equations now in function notation. Then it says write a piecewise to model this. So that means we're just putting everything all together, but writing it as a piecewise. So we're going to have our three equations. So that's the first thing I'm just going to write down. I've got the first one is 7 over 5x minus 14 and 5. The second equation we have is negative 5 over 9x plus 98 over 9. And the third equation that we have, it's just equal to 2. So we put 2 there. Now, the next part is we need to have our domain. So some people put the domain first and you lost marks for that. So the first one is it's equal to or greater than 2 and equal to and less than 7. Because it's already hit 7, we're just going to say it's greater than 7 and up to 16, equal to and less than 16. So then for our last one, we're just saying x is greater than 16. So that means there is no overlap. Determine the angle path B makes with path C. So again, we are thinking about our tangent relationship. So, because we know our tangent is opposite over adjacent, and that gives us our angle here. So we're going to use that. Tangent negative 1 of negative 5 over 9, and that's going to give us approximately negative is 29. So if I add 180 to my theta, I will then get 150.945 degrees. For D, justify whether path A and B is perpendicular. So for our gradients to be perpendicular, we need to be able to times them together and it should equal negative 1. So straight away, and that's the justification. So straight away I go to A, and A is 7 over 5. B is negative 5 over 9. And they do not times together to equal negative 1. So therefore, it's not perpendicular. So you would 1 mark for this, 1 mark for stating which is perpendicular or not. Okay. This is a question that we could have had multiple different answers for. So all it's saying for this question is we are wanting to look at a quadratic function of the form g with a domain of real numbers is graphed with all real numbers. G of x is equal to ax squared plus bx plus c. Can be used to model part of the our track. Suppose the linear pathway of B is changed to a quadratic, which passes through 7, 7, and 16 too. So if we've forgotten, those 2 points are listed are these points, these joining points. So I wrote it down so you didn't have to go back to this graph to look at it. It says, find the equation of the function of g of x. Now, there's multiple ways we could have solved this and done this. The easiest way I would think is by using 7, 7 as a turning point. So if we think about our turning point form, we've got x minus h squared plus k. Okay, so I've got it in this form here, and straight away I'm going to put in my values for k and h based on my turning point. So that means I've got y is equal to a, x take away 7 squared plus 7. So now the only thing that you need to do is find a through using the second point, which is 16 and 2. Just remember there are other ways to do this, but this is the easiest way. The second point is I'm just going to put those two values in and solve for a. 2 is equal to a in brackets 16 take away 7 squared plus 7. Okay, so we'll just simplify this now. So 16 take away 7 is 9. 9 squared is 81. So that gives me 2 is equal to 81a plus 7. Now I will take 7 to the other side. And that will give me -5, and then I'll divide everything by 81. So that will give me a is equal to -5 over 81. So this already helps me with II because I've done it in this way. The turning point for this one is just going to be 7 and 7. You could have done it in multiple ways. Now, from this point here, I still haven't finished off answering I. So I've got the equation already and I can write it out. Y is equal to -5 over 81. X take away 7 squared plus 7. Now to go to the next step, I would have just gone onto my class pad, gone on to interactive, gone down to transformation and expand, and plugged it in, and it would have expanded it for me into the form that I've asked, which is y is equal to -5 over 81 x squared plus 70 over 81 x plus 322 over 81. So this is the reason why, if you can look at these numbers, it's a class pad activity. You need to be able to understand everything, but you need to be able to use your CAS calculator to make it simpler. Okay. Transformation. Taking the base function y is equal to x squared, what are the transformations that map the base to this function? So this is why you need it to have it in turning point form, because it helps us. So straight away, we've got a dilation. Dilation factor of 5 over 81 from the x-axis. The negative there tells me I've got a reflection. So I'm using Dr. T here. So that's the first two things. Then I look at the transformation. We've got a vertical shift in the positive direction of 7 and a horizontal shift in the positive direction of 7. And we've got that right here. So again, that's really all we had to do. Now the final part. Now for this, there was a couple of interpretations of this, and I accepted both of them because with any question, if it can be misread in a different way and it makes sense, then I will apply it for both answers. So I'm going to do it in the way the question was meant. The inverse of a square root function can be used to model part A of the cycling track. Find the equation of the inverse if the graph passes through 0, 0, and 7, 7. Okay, so the first thing I'm going to look at is my original function is saying the graph must pass through these 2 points. So I'm just going to write it as h is equal to square root x. I'm then just going to put an a in and substitute my values of 7 and 7. So 7 is equal to a square root 7. Now I would like to get a by itself. Now we know that if a is square root 7, then both sides are equal. So straight away I can jump to that. So the next part is I'm just going to rewrite my equation. So I've got h is equal to square root 7 square root x. So this is where we are switching our values around. So x becomes y, y becomes x when we're talking about the inverse. So I'm just going to make that x is equal to square root 7y. Now we are just going to get y by itself. So I square both sides, and that will give me x squared is equal to 7y, and then I divide by 7. So y is equal to x squared over 7. From this point, I am then going to write it as a piecewise. So for my piecewise, we're wanting to look at the changes that we have created. So that means our first equation, let's go back up. So this is our B, and this is our A now. So our A is going to be 1 over 7x squared. Our B, I'm just double checking, is negative 5 over 81 x minus 7 squared plus 7. And our C hasn't changed, it is just going to be 2. Now, then I'm just going to put in my values. So x is going to be equal to and greater than 0, and equal to and less than 7. My second equation, it's starting off at 7, so it's greater than 7, and it's equal to and less than 16. And for the last one, x is greater than 16, but is equal to and less than is 20. So we need to be putting in our values. From this, we are going to put everything onto our Cartesian plane. Be mindful, make sure you are labeling everything. A lot of people are not labeling everything properly, which makes it a lot harder. So I'm just going to label everything as 5, 10, 15, and 20. Actually, I'm going to change that just because the boxes we have here will probably make it a bit easier for you to read it if we go by 4s. 4, 8, 12, 16, 20. It means I can be accurate with using those boxes. Likewise, if I then go up, I am just going to go by 10 and make this 5. Okay, so let's look at the first part. The first part says we are looking at the 3 points that we have. So the first point is going to be at 7, 7. That has not changed. So 7, I go up. Be that here. 7 and 7. The second point that I need to look at is at 16 when x is 2. So I'm just going to draw in my first graph, which is the easiest, which is just the 2. So from here to here, also make sure you put your endpoint as well of 20 and 2. So the next one is I'm going to graph is the B, and that is just going to be going here. Some people went and did it the opposite way and did it this way here. Make sure you're doing it correctly. You've got your CAS calculator if you need to use it. Okay. This now, last part is we've got is 1 over 7x, and we know that is a minimum, so we know it's going to be a bit more going starting at the origin here and going out and then going up towards it. So we've got our points. I've labeled everything, so that will give you full marks. And that was it.